Hello and welcome to the video on chapter 6 section or chapter 10 section 6. On this one is on solving radical equations. So our objective for this case is going to be to solve and to demonstrate methods on how we will solve radical equations. The whole point on solving radical equations, again from our reading, the whole point is kind of the methodology I'm going to use in this video is to double check and to make sure that the radical is isolated all by itself, and then we will raise to a power. So in this case I have the square root of 5x is equal to 6, and so as a check we can note that first we have a radical equation, and secondly we have to make sure that the radical is isolated, meaning it's all by itself on one side of the equal sign. And so for the square root of 5x we can see that it already is. So that being the case, I'll just rewrite my root 5x equals 6, and since it's all by itself, what we can go ahead and do is square both sides, because again we know that squaring and square rooting undo one another. So if I square the left hand side, I square the right hand side. So this is going to give me that 5x on the left-hand side, because the radical, or the root and the squaring undo one another, equals 36. So all I have to do now is to divide by 5, and we get 36 over 5, and there's nothing here that we need to concern ourselves with. And notice if I take this and plug it back into here, notice that the 5's will cancel out, so I get the square root of 36, and that is indeed equal to 6. So let's take a look at another example. It's solve the square root of 3x plus 1. So again, I can notice in this case I have a radical equation. And so again, the first thing we have to do is check that since we have a radical, is the radical isolated by itself on one side? And sure enough, we can see that this is the case. So we have the square root of 3x plus 1 equals 4. So I'll go ahead and square both sides to remove the radical, and this will leave me on the left-hand side that 3x plus 1 is equal to, and we have that 4 squared is 16. So I'll go ahead and subtract 1 from both sides, so that gives me that 3x is equal to 15, and then divide both sides by 3, so I get x equals 5. And again, I could take that x equals 5, substitute it here. So 5 times 3 is 15, plus 1 is 16, and we have that the square root of 16 is equal to 4. So in this case, we have that the cubed root of x plus 4 is equal to a negative 3. I'd just like to point out that since this is an odd root, note that we can have odd roots equaling to negative numbers, because we have the fact that the cubed root of negative 8 is negative 2. So we do take odd roots of negative numbers. Again, we can recognize that this is a radical equation, and we have to also have the fact that the radical is all by itself. And in this case, it is. So we're good to go. So I just rewrite here. Since we have a cubed root, this time we're going to have to cube both sides. So I take my equation, and if I cube both sides, all right, we know on the left-hand side it's going to reduce down to x plus 4. On the right-hand side, we know that negative 3 times negative 3 times negative 3 is negative 27. So if I subtract both sides by 4, I get x equals negative 31. And again, notice if I plug negative 31 plus 4 is negative 27, and the cubed root of negative 27 is indeed negative 3. Here we have to solve the square root of 5x minus 4 minus 1 equals 3. So again, I'm recognizing there's a radical inside this equation, but while notice in this case the radical is not isolated. So what we're going to have to do first is to isolate the radical. So note, to do that, all I have to do to get it all by itself is to add 1 to both sides. So adding 1 to both sides gives me that the square root of 5x minus 4 is equal to 16. All right, and now to remove the radical, I will square both sides. So on the right side we get 4 squared. On the left side we remove the radical, and I end up with 5x minus 4 equals 16. go ahead and add 4 to both sides. I get 5x is 20. Dividing by 5, we note that x equals 4. So let's go ahead and double check. So substituting our 4 into here, 5 times 4 is 20. 20 minus 4 is 16. Square root of 16 is 4. 4 minus 1 is indeed 3. So a popular thing to take a look at is this thing known as the Pythagorean theorem. So I'm thinking that at some point in time in your life that you have seen or at least heard this before. Now, the Pythagorean theorem works only with right triangles. So if you'll notice my triangle down below, this is a right triangle because right here we have a 90-degree angle. And we know that the side opposite the 90-degree angle is called the hypotenuse. So we know from the Pythagorean theorem that we have that the sum of the squared sides, so a squared plus b squared, has to equal c squared. So we can use this to solve some very simple geometry type questions. So let's take a look-see. So here I have to find the length of the unknown side. So on the left side here we have a 12-foot. Down here on the bottom we have a 6-foot. And across from the right angle we have our hypotenuse. So we know that 12 squared plus 6 squared has to equal to, just call it x squared. So 12 squared is 144. 6 squared is 36. So we still get our x squared. Adding 144 and 36, I get 180 equals x squared. So to solve for x, we just say x is the square root of 180. So 180 can be re-expressed as 36 times 5, where 36 is a perfect square. So we could take that out of the square root, which comes down to 6 times the square root of 5. Let's take a look at one more example. So here we have that the left side is 5, the hypotenuse is 9, and notice that down here is our unknown side. So why don't we just go ahead and call our unknown side x. So again, by the Pythagorean theorem, we have that 5 squared plus x squared has to equal to 98 squared. So 5 squared we know is 25, and on the right side, 9 squared is 81. So to solve for x squared, I'll go ahead and subtract 25 from both sides. So that brings me down to this line here. So x squared is 81 minus 25, which gives us 56. So solving for x, we have to take the square root of both sides. So that means x equals to the square root of 56. So now we have to simplify the square root of 56 using our techniques from previous sections. So we get the square root of 4 times 14. And the 4 comes out of the square root as a 2. So our final answer here would be 2 square roots of 14. Alright, so I hope this video helps. Remember, the bottom line on solving radicals means we have to get the radical all by itself. And then once we get the radical all by itself, if it's a square root, then we square root both sides. If it's a cubed root, we cube root both sides. If it's a fourth root, then we fourth power both sides. All right, if you have any questions regarding this, please be sure to mention them in our warm-up exercise. And if you have any other questions in class, be sure to be more than happy to discuss any of that. All right, thanks a lot, and we'll see you in class. Adios.